So friends, in this video we will learn about the relationship between current and drift velocity. So first of all, we will draw a diagram of a wire enclosing the charge, enclosing number of electrons n. So this wire have n number of electrons, n electrons. We don't know. Its length is L, its height is H, and its I can say breadth is, imagine it is a rectangular wire, so its breadth is also there. It too has a breadth. So n is equal to number of electrons, and so the number of particle density or number density is equal to, or electron density is equal to number of electron divided by volume. We know density is equal to anything by volume. Density is a volumetric term. So I can say that I can also write volume as length into breadth into height, or I can say that breadth into height is equal to area and length is L. So I can say that breadth into height is equal to area and L, AL. So I can say the volume is equal to AL. So number of electron is equal to N by AL. It will give me the total number of electrons. It will give me the number of electrons in unit volume. So I have founded the number of electron in unit volume. So I can say that the purpose of this was to actually find the charge. We know that charge is equal to number of electron into charge on electron. So I have founded that in a unit volume there is N by AL electron. So in a whole wire there will be N, which is number of electron in a unit volume, which is number of electron in unit volume. Okay, so N is number of electron in unit volume into area into length. So number of electron in unit volume into whole volume is equal to total number of electrons into charge on electron. So I can say that Q is equal to NaLe. I have found it out. Q is equal to NaLe. So in order to write it in the form of charge, I can say that in order to write it in the form of charge and to determine the relationship with drift velocity, first I have to say that find out what is drift velocity. Drift velocity is equal to, actually its expanded form is equal to electron into electric field divided by mass into tau. So we need not to write it in the expanded form, but we should know that what is actually velocity or drift velocity, as velocity is like as speed, but it is in vector form. So we know that speed is equal to distance upon time, so velocity 2 is equal to distance upon time. So actual distance is here is equal to L, and so distance upon distance is L, and time taken is always T. So we know that charge is equal to Q by T. Okay, but we should first find the value of T. So we will find it as it like Vd into T is equal to L, and or T is equal to L divided by Vd. Okay, so so we have found the value of T is equal to L by Vd. So I will be equal to Q. What was the Q we find out in the earlier? It was N A L E, okay, divided by T. What we found out, T is equal to L by Vd. L divided by Vd. L cancels this L. I is equal to, and this Vd moves upward. I is equal to Na Vde. So we found out that I is equal to Na Vde. Hence we find it I is equal to Na Vde.